Hi there and welcome to our first math lecture. We will be covering Unit 1, Whole Numbers. Mathematics is a key skill for us as surgical technologists. As a surgical technologist, you already know that accuracy is important. Being competent in whole number concepts like addition, subtraction, multiplication, and division forms a basis for successful computations that you'll have to do on the job as a surgical technologist. These basic skills, like I said, are the foundation, and many people are afraid of them, but there's no need to be afraid. Don't fret. We will get through this together. We'll work through it together. Just approach this class matter-of-factly, and just remember as we go through this that math is a job skill and a life skill. So what is a whole number? A whole number is a positive number like 3 or 356. Whole numbers do not include fractions like 3/4 or 3/4, or a decimal number such as 0.75. We use whole numbers in our everyday lives to add calories, count medicine capsules, maybe calculate wages, and measure different things. As a surgical technologist, we use whole numbers when we are performing our counts. So as healthcare professionals, we need to be aware of the information conveyed through whole numbers. These numbers are used in meaningful ways to convey important information. For example, whole numbers appear in several places. Over-the-counter drug packaging is an example, and other whole numbers also appear on prescription drug labels. You might see things like the National Drug Code number, temperature for storage instructions, as well as other identifying numbers such as lot numbers and expiration dates. When we're aware of these numbers, we see that they are meaningful. And in the operating room, we will be reading and verifying medication labels prior to bringing them onto the field. We will be creating a label to go on a syringe or a graduate or some sort of medicine cup. And so it's very important that we're able to identify these components of the drug label. So what other uses of whole numbers in the context of healthcare can you think of? I would like to encourage you to pause the video and think about 10 different examples of how whole numbers might be used in the role of a surgical technologist. Also think about the information that those numbers would provide with the examples that you came up with. So here's an example for you. There's a drug label here for you, and there are some whole numbers on this drug label, and I'm going to circle a couple of them for you. The first one is the number of capsules. Can you find it on here? It is actually, if I can do this, is right here, 100 capsules. And then also, can you find the other one right here? Each capsule containing 30 milligrams of medication. Whole numbers and their opposites are called integers. For example, if we have a positive 5 and a negative 5, both are considered integers, and they are also opposite of one another. Sometimes we will see a number and it doesn't have any sign in front of it at all, and so we assume that it is a positive number. Here we see a number line, and number lines are used to visualize integers and their relationships with other integers. So you'll see on your screen a number line that starts with -10 at the far left and ends at 10 or +10. Positive sign is not shown on the far right. The numbers on this line are labeled with integers increasing in order from left to right. It extends in both directions, to the right for positive numbers and to the left for negative numbers. So, like we said, the number line extends in both directions. And it's important to remember that any integer is always greater than the integer to its left. In negative numbers, the closer a negative number is to 0 on the number line, the larger the number is. For example, a -3 is larger than a -19 because -3 is closer to 0 on the number line than the -19 is. Another couple examples here, +4 is going to be less than +5, right? Because it's it's closer to the 0, 4 is. If we look at the negative counterparts to those numbers, a -4 is going to be greater than a -5, again, because it is closer to the 0 on the number line. Symbols are often used to show the relationship among numbers or items, and we've all seen the equal sign before. In this first example, you can see 1 + 7 = 8, and you'll notice that both sides of the equal sign are equal to each other. Now let's look at some of the other signs. When we have a sign that is the opening is facing to the left, this sign is showing that one number, in our example here 19, is greater than the number 6. In the second example, the sign is going the other way, it's opening to the right, and this sign shows that 5 is less than 12. And the way that I learned this in grade school was the alligator eats the big number, and that's how I always remembered which way to situate the sign. The next example, you'll see age, and then there is a sign that's opening to the right, and then there is a 5. So this means that the age is less than or equal to 5. And then the last example, we have the sign facing the other way, which would be read as the weight is greater than or equal to 10 pounds. All right. Moving forward, a number statement. A number statement or simple equation shows the relationship between numbers, operations, symbols, or other items. It can be a short phrase like 44 is greater than 34, or it can be a long sentence like $1 plus 2 quarters is greater than $1.35. Other examples might be -5 is greater than -17, or 12 p.m. is equal to noon. A number statement or simple question shows the relationship between numbers, operations, symbols, and other items. Again, it can be a short phrase or it can be a longer phrase. So let's move on and talk about addition. Addition involves combining 2 or more numbers to find the sum. Addition can be written out in one line, like 2 + 1 = 3, or it can be lined up in columns for easier adding, like you see on the bottom of the screen. When you are adding numbers, it is important to line up the addition problem according to the value of each digit, from the smallest digit to the largest, and then work your way to the left. It's important to remember to carry your extra digit to the place value to the left. So what if a column adds up to more than 9? Again, carry the left number from this column to the left and add it to the numbers in the left column. This is called carrying. So here's an example. A problem is set up vertically, and we see 7 and 5 equals 12, which is too big. So we're going to write down the 2 of the 12, and we're going to carry the 1 of the 12 to the left, and we're going to place it next to the 3 there. I usually do a little like subscript up at the top, and then you would add 1, 3, and 2 to get 6 for an answer of 62. So inventory is an important clerical function in the healthcare industry. Supply technicians, clerks, nursing assistant, and other staff will sometimes perform this work, so keeping accurate inventory reduces overstock and helps avoid the problem of understocking medical supplies as well. For those of you that already work in the medical field, or you've had some other type of job where you go to get a supply and it's not there, that can be really frustrating. So take the following example. So your boss asks you to take inventory and add up how many medicine cups there are in the operating room. You are going to simply count how many are in each room and then add up the numbers for the total that are in the department. So here you can see an example of room 1, there were 15, room 2, there were 25, room 3, there were 10, room 4, there were 20, and then there was a supply closet that had 10. So we're going to go ahead and add those up, and we start on the far right column, and we do 5 plus 5 is 10, and so we put the 0, and we carry our 1, and then we add our 1, another 1, 2, 1, 2, and 1, and that equals 8, and that will give us our total of 80 cups that we found in the department. Intake and output totals also require addition, and we do this in the operating room as surgical techs with how much medication we started with and how much medication, if there was additional medication that was added intraoperatively, or how much the surgeon injected into the patient, or how much was irrigated. Those kinds of things all require those skills. So measuring output, or how much medication was used, is important because it helps us ensure a patient's health and safety. Unlike household measurements, which are measured in cups, healthcare patients' intakes and outtakes are measured in milliliters, and so is medication that is used in the operating room as well. Previously, you might have heard of cc, or cubic centimeter, and it is still used and appears on occasion, but metric units of milliliter and liter are the standard units of measure for volume today. Intake also includes oral ingestion of fluids and semi-liquid fluid, intravenous feedings, tubal feedings, and blood as well. Output includes liquid bowel movements or diarrhea, urine, emesis, irrigation, and gastric drainage. Intake and output comparisons require additional skills. So assuming you recorded the patient's intake and output, if the intake total is 1,970 milliliters and the output total is 1,205 milliliters, has the patient had a greater intake or output? So we said that the patient had an intake of 1,970 milliliters and an output of 1,205 milliliters. So the intake is greater than the output. So what do we know? What does this? Well, here we see that a nurse has kept track of the patient's output during the day. Diarrhea happened twice and was recorded as 100 and 200 milliliters respectively, for a total of 300 milliliters of diarrhea. Urine was passed 4 times and was a total of 720 milliliters. Gastric drainage was also recorded in the third row as 40 milliliters and 35 milliliters. For a total of 75 milliliters, and then emesis was recorded once at 110 milliliters. Adding all of these together, we get an output, a total output at the bottom right column there of 1,205 milliliters of total output. So now we're going to move on to subtraction and talk a little bit about that. Subtraction involves taking one number away from another number. So to subtract, we're going to line up the numbers according to the place value and justify them to the right. So we're going to line all the numbers up according to the right-hand column. Fewer errors occur if you set up your problem vertically up and down instead of going across. So we want to start with the right side of the math problem, and we're going to work our way to the left side, subtracting each column as we go. So here we can see this problem on the bottom is set up vertically, which oftentimes is a lot easier for us to compute. So we're going to start with the right side of the math problem and work our way toward the left side, subtracting each column as we go. In this example, we have 89 minus 31. So we're going to start in the far right column and do 9 minus 1, and that gives us 8. So we're going to write that down. And then in the next column, we'll move to the left. We have 8 minus 3, which equals 5, and that will give us our answer of 58. So what if a number can't be subtracted from the number directly above it? In that case, increase the value of the top, smaller number by borrowing 1 from the column to the immediate left and reducing that number by 1. For example, if our problem is set up vertically and we start on the right side and work to the left, if we have a number on the bottom like 5 and a number on the top like 1, then we're going to need to borrow from the column to the left to be able to subtract properly. When we do that, we're going to reduce the top number in the left column by 1. Okay, so here we can see an example. We have 381 minus 65. All right, so we're looking at that far right column. The 5 cannot be subtracted from the 1, so we will borrow 1 from the 8, and that leaves 7 in that column after we take 1 away. And we're going to put the 1 with our other 1, which gives us 11 now. And when we do 11 minus 5, we get 6. Then we can move to the next column to the left and subtract 6 from 7, which gives us 1, and then we bring our 3 straight down, and that gives us an answer of 316. In subtracting, it's easy to check our work to make sure that we're not making careless errors. The way that we do this is by boxing the answer and the number subtracted, so the smaller number. And then when we add those together, we should get the top number. So here's an example here. If you see in the left column, 381 minus 65, our answer that we came up with was 316. However, if we add the smaller number and our answer, we should get the top bigger number. So this is an easy way for us to check our answers. So subtraction can also be used during inventory. So we talked about previously how addition can be used during inventory, and subtraction can be used during inventory as well. So for example, let's say at the beginning of the month, a dental office started with 2,258 latex examination gloves. On the last working day of the month, 784 were left. How many gloves did the dental office use during the month? So here, we want to take the total number of gloves we started with, which is 2,258, and then we would subtract the number that remained, 784. This is going to give us the number of gloves used, which is 1,470. So here you can see how we worked this out. We took 2,258 and we put that at the top, and then we right justified 784, which is what was left, and then we went ahead and performed our subtraction. So 8 minus 4, we're starting in the far right, equals 4, and then we can't subtract 8 from 5, so we have to borrow 1 from the 2, which makes that 2 a 1, and the 5 becomes a 15, so now that's easy for us to do. 15 minus 8 equals 7, and then we go to the next column to the left, which is the 2 and the 7, but we borrowed 1, so now we have 1 minus 7, and we can't do that. So we got to borrow from the next 2, which gives us an 11, and 11 minus 7 is 4, and then we bring our 1 straight down, and that gives us our answer of 1,474 gloves used. So here's another example. Here we have Dr. Brown having a total of 13,576 patient files. If he sees 8,768 of these patients during the summer, how many remain to be contacted for an appointment? So the way that we're going to set this up is the 13,576 is going to be the top number, and we're going to right justify the bottom number and place that underneath. That's 8,768. So I'm going to give you a second to work this out, and then we will talk about how we get to our answer. All right, so here is how we're going to work this out. Again, the 13,576 is on the top. Then we right justify the 8,768 patients that Dr. Brown has already seen. And then we're going to go ahead and do our subtraction starting with the far right column. Now we can't subtract 8 from 6, so we have to borrow, giving us a 16. And 16 minus 8 equals 8. Then we have our 6 minus 6 in our next column, which gives us a 0. Now we can't subtract 7 from 5 easily, so we have to borrow from the 3, giving us 15 minus 7 equals 8. And then we move to our next left column, which is 2 minus 8, which we can't do easily, so we're going to borrow from the 1 on the left, and that gives us 12. And 12 minus 8 is 4, and that gives us our answer of 4,808 patients left to be contacted to schedule an appointment. All right, we're going to move into multiplication. So multiplication is repeated addition. It tells you how many times to repeatedly add the same number. For example, you see the first one here is 5 times 3. So when we write that out, it's really 5 plus 5 plus 5, 3 times, right? And that would give us 15. Another example is 15 times 5. So we're adding 15 5 times, and that's going to give us 75. Here is a multiplication table. You might remember these from a long time ago, but memorizing multiplication tables is really important for us to be able to perform mental math. If you're dependent on a calculator or have forgotten some of the tables, it's important to refresh yourself with those multiplication tables. And here's a chart. There is also a chart in your book. You can find that in Appendix E. It's important that you memorize multiplication tables for the numbers 1 through 12 and also for number 15. Students and individuals in the healthcare field, surgical technologist is included, frequently use multiplication. And as a surgical tech, if you're at the field and you're scrubbed in and you're sterile, you are not going to have access to a calculator. So memorization of these is essential. So how do we multiply? Well, to multiply, we're going to line up the numbers, again, according to place value. We're going to put the largest number at the top of the problem. And this will help us to avoid making mistakes or careless errors. Remember, when we're multiplying and not adding. Also remember to move the numbers from the second and succeeding lines over one column to the left, because you'll have to do addition if there's multiple numbers in the problem once you are done doing the multiplication. So here we see an example. We have 123 times 23. So to multiply, we're going to line up the numbers by place value, right justified, so ones, tens, hundreds, etc. We're going to put the largest number on the top, and we're going to work from right to left. So first we're going to multiply 3 times 3, and 3 times 2, and 3 times 1, which is going to give us 369. Now, for me, it's helpful when I'm starting with that second number, the 2, to put a 0 under that ones column. That reminds me to shift over to the tens place when I start multiplying by the 2. So then we're going to multiply 2 times 3, and 2 times 2, and 2 times 1, and that gives us 246. And then we're going to go ahead and do our addition. And if we need to carry, then we're going to carry our numbers. And once we get done with that, we should get 2,829. So here's an example. The lab ordered 111 tests for its staff. They cost $234 for each test. We want to know the total cost of the order, right? So when we multiply, we're going to multiply 234 times 111 to get the total cost. So I'm going to allow you to, or ask you to, pause the video and do this quick multiplication problem, and then resume to check your answer. So here we are trying to find out what the total cost is of 111 tests that cost $234. So when we line them up, we're going to multiply the first, we're going to multiply the top number by 1, and then we're going to shift over to the tens and multiply the numbers by 1 again, and then we're going to shift one more time to the hundreds place and multiply the numbers by 1 again. And that is going to bring us to our answer of $25,974. So when two or more factors are multiplied, they form what is called a product. So when we add two numbers together, we get a sum. When we multiply factors together, we get a product. And a factor is a number that divides exactly into another number. So we're going to look at prime factorization next. So in the examples that you see on the screen, you see that 48 has any number of factors and that each of those factors divides exactly into it. So we have 4 times 12, and we if we multiply those together, we get an answer of 48. So if we look at the factoring, we have factors of 4, 2, and 6. To give us a product of 48. So here we see that a prime number is a number that is a product of only one and itself. Nothing else will multiply to give you that number. So 2, 5, and 7 are prime numbers, but 6 and 8 are not prime numbers. We review prime factorization in this unit because it's a foundational skill that will help us to complete other math functions. For example, factoring will help us figure out divisible numbers for division or arrive at common denominators and find equivalent fractions. Furthermore, solutions are expressed in their simplest form, or should be expressed in their simplest form, which means that you may need to rely on factors such as 10 times 4 to the second power in writing out the units in a solution. So here we see a factor tree, and this is the way I learned to do factoring. A factor tree is used to diagram the prime factorization of a number by continually breaking each number down into its primes. For example, here we see the factor tree of 48. If we first break 48 down into what two numbers we could multiply to get 48, we could use 4 and 12. We could use 6 and 8, right, which is 48. All right, so if we take the example on the left of 4 and 12, then we look at the numbers 4 and 12. What factors can we multiply together to get 4? Well, that would be 2 times 2. And what factors could we multiply together to get 12? And we could use 4 times 3. Can we factor out 2 anymore? Well, no. We said that 2 is a prime factor, and then we can't factor out 3 anymore because there's nothing else that's going to multiply to give us 3 besides 1. And then we look at our 4, and so now we can show our prime factorization as these most basic numbers here, which is 2 times 2 times 2 times 2 times 3, right? We have 4 2's and we have a 3 that we factored out. And if we multiply all of those together, we get 48. We can also write it in a different way and write 2 to the 4th power times 3, which would give us 48. And there's another way we can write it as well. Instead of using a dot to symbolize the multiplication sign, we can put parentheses around each, which signifies us to perform the operation of multiplication as well. So let's put these two concepts, factorization and prime numbers, together. A prime factor is a number that is the product of only one in itself, right? We said that before. The prime factors are always the same for any number. So prime factorization, when you write a number as equals when you write a number as a product of prime numbers. So let's look at the example. We have two factors, a 16 and 3, and that gives us 48. But we know the prime factors of 48 are the 4 2's and the 3. That gives us 48, right? So the final answer in factorization should be expressed in the simplest form. So in this example, 45 would equal 3 to the second power times 5. Not in the simplest form is the second example, which is 45 equals 9 times 5, right? Because we can factor out 9. 3 times 3 equals 9. So then that would take us back to our simplest form that you see in the first example. All right, moving on to division. So division is the act of splitting numbers or amounts into equal parts and or groups. To divide whole numbers, we determine what number is being divided into smaller portions, and then we determine the portions. Division can be expressed in many ways. It can be expressed with the division sign that you see in the first example, with words like 27 divided by 3 equals 9. It can also be symbolized by a slash, like you see 27 and then a line or a slash and 3. That means 27 divided by 3. All right? It can also be represented by the long division symbol. All right? Setting up the problem correctly is what is going to ensure that we find the correct answer. So let's talk about terms for a moment. 81 is the dividend. That's what's being divided up. 81, okay, so let's look at the sample. 81 divided by 3 equals 27. So in this example, 81 is the dividend. It's what we're going to separate out into 3 separate parts, right? So that means 3 is the divisor. That's going to be like if I have 81 candy canes and there are 3 of you, how many candy canes are each of you going to get? Well, that number would be 27, and 27 is the quotient. So how do you work a long division problem other than by using a calculator? So let's talk through one now. So first what we want to do is underline the number of places that the divisor can go into, and then write the number of times the divisor can go into the dividend on the quotient line. We want to place that directly above the underlined portion of the number. This helps you keep track of the process. We want to multiply the number by the divisor and place it below the underlined portion of the dividend. Then we're going to subtract the numbers, all right? Next, what we want to do is bring down the next number of the dividend using an arrow to keep the numbers aligned, right? That way we can keep track of which numbers we've worked with. And then we're going to continue to repeat steps 1 and 2 until the number left over, if there's any number left over, would be referred to as the remainder. All right, so here we have an example of 5,492 divided by 34. Right, so we're trying to figure out how many 34s are in 5,492. So we're going to ask ourselves, can 34 be divided into 5? No, 5 is too small, right? So then we have to look at 54. So can 34 be divided into 54? Yes, it can. It can go once, right? So we put our 1 up there. We do 34 times 1, which equals 34. And then we have to do some subtraction. And that leaves us with 20 left, all right? So once we do that, then we're going to bring down, well, we're going to ask ourselves, does 34 go into 20? And the answer is no. So we're going to bring down our next number, which is the 9. We're going to drop that down. So now we have 209, and 34 will definitely go into 209. Okay, it goes in 6 times, and that gives us 204. And then we do our subtraction, and that leaves us with 5. So we still have one number left. We got to bring that down, 52. And we ask ourselves, how many times does 34 go into 52? Again, only once. And so we do our multiplication, and that is 34. And we get a leftover of 18. Does 34 go into 18? No. So that is going to be our remainder. So now we have 161 with a remainder of 18 being our answer. Okay, so here's an example problem. We're talking about carbohydrates. Carbohydrates have 4 calories per gram. So if we have a serving of soup and it has 368 calories of carbohydrates, how many grams of carbohydrates are in that serving? So let's set up the problem. It's asking how many 4s are in 368. So let's divide the 4 into 368. So we're going to start by dividing the 4 into 36 because 4 does not go into 3. So 4 will go into 36 9 times. We're going to multiply 4 times 9. That gives us 36, which when we subtract that, we get 0. We have one number left still up there, so we bring it straight down, and then we ask ourselves, how many times does 4 go into 8? Well, it goes in evenly, exactly 2 times, right? So 4 times 2 is 8, and when we subtract, we get 0. So our answer is an even number, an even distribution with no remainder. We get an answer of 92, right? So there are 92 grams of carbohydrates in that serving. All right, so solving for the unknown number. So sometimes number statements in math class ask for an unknown number. So looking for an unknown number is an aspect of algebra. So to solve these problems, we have to understand the relationship between the numbers. For example, if we have something that is blank plus 12 equals 75, how are we going to find out what number we put in the blank? Well, to find that out, we're going to need to subtract 75. We're going to need to subtract 12 from 75. And that is going to give us the unknown answer, which is 63. And you can see that operation performed here at the bottom of your screen. Using addition, we can also solve for unknowns. So let's look at another problem. Now we have 12 equals blank minus 23. All right, so how are we going to find that out? Well, if we add 23 and 12, we're going to find out the number that we put in the blank. And if we add those two together, that is going to give us the unknown number of 35. So can you see how addition and subtraction are related? So using subtraction to solve for unknowns, here is an example. We have 49 plus blank equals 107. Or 49 plus what would equal 107. So the way we get to this number is we're going to subtract 49 from 107, and that gives us the answer of 58. So here we are using multiplication to solve for an unknown. So our problem is what divided by 16 equals 4. So if we multiply 16 by 4, we get 64. And then we can check to see if our work is correct, right? We can do 64 divided by 16 and see if the answer really is 4. So here we are using division to solve for unknowns. And our problem here is what times 31 equals 279? So if we divide 31 into 279, we get 9. So 9 times 31, we can go ahead and work it out and see if it comes out right. 9 times 31 equals 279. If we find that that is true, then we know that we have properly solved for the unknown. So let's talk a little bit about rounding. Whole numbers all have something called a place value. And the place value is a value determined by their place or by their location. Who would have guessed? So let's take the example of the number 5,281. 1 is how many ones, right? So it's the far left or far right, is the ones column. And then if we move to the number 8, which is one jump to the left, we find the tens column. So the 8 is how many tens, and then if we move another jump to the left, to the 2 is how many hundreds, right? And then if one more jump to the left is the 5 is how many thousands. So if you add up the ones, the tens, the hundreds, and the thousands, you are going to get 5,281. So remember that whole numbers have place values. We just said that. By using the place values in a number, we can do something called rounding the number to a particular and specific place unit. So rounding means reducing the digits in a number while keeping their values similar. You'll see that squiggly little line is called a tilde, and that indicates approximate, right? So 102 is approximately 100. 98 is also approximately 100, all right? So rounding is valuable because it helps to estimate supplies or inventory or countable items to the nearest unit. Now, when we're counting in surgery, we don't round and we don't estimate. But if we were doing inventory or something like that, we could definitely use rounding. So, for example, it is okay to know that you have approximately 100 medicine cups left. You don't need to know that you have exactly 102, right? The number 100 is far easier to remember in order to know that you have enough for a while, right? Rounding is used a great deal in healthcare, such as in inventory and packaging of supplies, as well as in daily activities. However, rounding isn't always appropriate. Like I said, when we're counting our surgical supplies during surgery, rounding is not appropriate. But if we were doing inventory, which a lot of facilities, all the staff participates in that, it would definitely be something that we could use, right? So let's look at this problem. We want to round 7,872 to the nearest hundred, right? So rounding is accomplished in 3 steps. First, we're going to locate the hundreds place. We got to figure out where that is, and we're going to underline it, right? So that we know which one we're looking at. So we're going to circle the number to the right of the underlined number, and that's the number we're going to round, all right? So if the number you circled is a 5 or bigger, you are going to round up. You're going to add 1. If the circled number is less than 5, 4, 3, 2, or 1, or 0, you are going to round down to the next smallest number, right? And it's important to use zeros as placeholders if the ones in tens places, for the ones in tens places that we don't care about, right? So the final answer for 7,872 rounded to the hundredths is 7,900 because we're going to underline, right, the hundredths place. That's what we're rounding. We're going to circle the number that is to the right of the number we want to round, and we're going to determine, is it 5 or more, or is it less than 5? If it's less than 5, then we're going to go ahead and round it up 1, adding 1 to make it 7,900. All right, so let's talk about an estimation. Now, estimation provides an answer that is general and not specific. So rounding is going to help us to get to this general answer. So again, similar in the last couple slides we've been talking about, if we have $24.67, that's roughly 25 bucks, right? Or if we have $24.32, that's roughly $24, right? Because 32 cents is less than half. In the first example, 67 cents is more than half, more than 50 cents, so we're going to round up. If it's less than 50 cents, we're going to round down, right? Another example could be, an hour and 25 minutes is roughly 1 hour, right? Because 25 minutes is not quite half of an hour. So we're going to round down. But if we were estimating an hour and 55 minutes, for example, 55 is much more than half of a full hour. So we're going to go ahead and round up, and we would estimate an hour and 55 minutes as 2 hours. So the general principle with estimation is, first, again, we're going to find the midpoint. For money, we said it's 50 cents, and for time, we said it's 30. So again, if we have 50 cents to 99 cents, we're going to round up. Or if we have 30 minutes to 59 minutes, we're going to round up. But if we have money that's 1 cent to 49 cents, right? That's less than half. We're going to round down. And same thing for the hour. If we have 1 minute to 29 minutes, we're going to round down because it's less than half. Okay, so let's look at this example. So we're looking at Bob's expenses. So we want to estimate Bob's expenses for his co-payments for his dental, all right? So he's had 4 checkups, and we want to estimate them to the nearest dollar. So first, we're going to estimate each expense by rounding the numbers for easier adding rather than using the exact numbers. And then we're going to add them up, and that's going to give us the total estimated expense. So if we look at the first one, it's $65.85. Now let's ask ourselves, is 85 cents more than half of a dollar? Yes. Okay, so we're going to round up to 66 bucks. Then the next one is $59.10. The 10 cents is less than half a dollar, less than 50 cents. So we're going to round down, and we're going to keep our 59 bucks. Similar with the next one, $62.75. 75 cents is more than half of a dollar, so we're going to round up. And then the last example, we would keep it at $58 because 25 cents is less than half of a dollar. So then we can go ahead and add all of those up quickly and easily, and we get Bob's estimated expenses for his co-payments for his 4 dental checkups to be $246. All right, so statistics. Statistics is the study of the collection, organization, analysis, and interpretation of data. And it's super fun. People do this for a living. I think it's kind of crazy. But statistical analysis refers to a collection of methods used to process large amounts of data and report overall trends. So all of us have heard such and such a study came out and this percentage of this people said this, or this number of people experienced this. Whatever the case may be, those numbers, what we call quantitative data, right, are what they're referring to as statistics, okay? So the basics of statistical analysis include the topics of the mean, which is the average, the median, the mode, and the range. And each of these topics deal with groups or subsets of numbers and their relationships to each other and relationships to each other and to the set as a whole. So like I mentioned, the mean is also called the average. And an average is a number that represents a group of the same unit of measure, right? You can average dollars and minutes and pounds and grams. You couldn't average those things together, all right? So an average is going to provide a general number that represents this group of numbers as long as all the numbers are the same units, okay? Averages are going to be useful in health occupations because they provide general trends and information. So you will be using addition and division to compute averages. So let's look at an example. So Mary wanted to know the average score of her tests, maybe math tests. So here's a list of her scores. Now let's look at the units of measure. Are they all the same? Yes, they are percentages, right? So here's her scores: 92%, 79%, 100%, 89%, and 95%. So how do we figure this out? Well, the way that we figure this out is we're going to add up all of the grades, all of those percentages, and we're going to get a total. And if we were to add all of those up, we would get 455%. And then we're going to look at how many test grades there were. So there's 1, 2, 3, 4, 5 test grades. So we're going to divide 455 by 5, and that's going to give us an average. So when we do that, we work out that math, that gives us an average of 91%. So let's look at that. So here you can see we took all the grades, we added them together. That's the first step. And the second step is that we divided that total by the number of grades. All right, there were 5 grades that we were given. So 455 divided by 5 equals 91, and that is Mary's average grade, okay? So let's talk about the median. The median is a middle number in a list of numbers that are arranged in order from smallest to largest. So the median is literally the measure of the center of a data set. Remember, we're talking about statistics still. So for half, the data is below the median, and the other half has values above the median. So the median is useful in healthcare when we're looking at data or information that has a lot of variance or extreme values, because the median helps us to group that information around a center number. One example is looking up data from a flu outbreak. The median would help generalize or center the data. So when we compute the median, the first step is going to sort the list of numbers from smallest to largest. Then we're going to find the middle number to get to the median. Now, there's one little caveat here. If we have a list that contains an even set of numbers, we're going to need to add the final 2 numbers together and then divide that sum by 2 to get to the median. Right, so let's look at an example. So we're back to Mary again, and we're looking at her same test grades. So before we wanted to know the average, right, or the mean. But now we want to find out the median score on her tests, all right? So the first thing that we need to do is to get these guys in order of smallest to largest. So let's look at that on the next slide. So here we are, we ordered Mary's 5 grades, and when we put them from smallest to largest, we get 79, 89, 92, 95, and 100. Okay, we ordered them. So now what I typically do is, let me get my little marker out and I'm going to show you. I start by slashing the outer ones. So I'll put a line through this outer one. Oh, that is a little bit difficult to tell what that color is. Let me get a different color for us. All right, so I'm going to take out 79 at the end. I'm going to take out 100 at the other end. And then I'm going to slash my next ones and my other one here. And then that is going to give us the remaining one of 92. So Mary's median grade was 92. All right, so let's look at the mode. The mode is the most popular value or most frequently occurring item in a set of numbers. So to locate the mode of a series or listing of numbers, we're going to identify the number that is occurring the most. Now you can have more than one mode. You might have a list of 20 numbers and you find 10 occurring frequently and 5 occurring as frequently, right? So you can have more than one node or mode. So let's look at an example. Let's look at Bob's calories for his snack food for the weekend. Okay, so on Saturday, he has a series of snack foods and the calories are listed there, and then on Sunday, the same laundry list. So what is the mode? Well, the way we're going to figure this out is by looking for the number that is occurring the most frequently overall, and that number is 120. So 120 would be the mode. So the range of a set of numbers is the largest value in the set minus the smallest value in the set. So note that the range is a single number and not many numbers. So to calculate the range, what we're going to do is find the smallest number and then find the largest number, and we're going to subtract the smallest number from the largest. So let's look at that. Okay, so here we are, we're working on finding the range. So the first thing that we're going to do is locate the smallest and largest numbers. All right, we're gonna locate the smallest and largest numbers. So take a second, kind of scan down this list and locate the smallest number. Now look at the list again and find the largest number. So what we're going to do is subtract those two numbers, and when we do, we will get the range. So let's see how we work that out. Did you locate the smallest number as 12 and the largest number as 100? If you did, awesome job. So now all we have to do is subtract 12 from 100, and that gives us 88. And that tells us that the range of patients' ages was 88 years. Okay, so let's look at time in allied health. So in healthcare, we don't use the regular clock time that we do in the civilian world, right? We use universal time, or what's called military time, and military time is based on a 24-hour clock, which begins at 0001, which is 1 minute after midnight, and continues for 24 hours. So like I said, universal military time is based on a 24-hour clock. We have already been using this. It avoids the AM and PM confusion, and it begins at 0000 hours, and that equals midnight. All right, so if we have 0001, that's 1 minute after midnight, 0002, 2 minutes after midnight, so on and so forth, all the way to 23:59, which would be 11:59 p.m. And just a note that colons are not used when we are using universal time or military time. So here is an example. Here we have this standard time and with a clock, and looking at that, we can't tell, is this 2 o'clock in the morning or is it 2 o'clock in the afternoon? But with universal time, we can. It's easy to distinguish, is it morning or is it night? So all hours in universal time are going to have 4 digits. So an example would be, we would typically write this as 1 A period M period or 1:00 A period M period. If we're using universal time, it's going to be 0100 hours. 10 a.m., the example would be 1000, right? 1000 hours. And then once we get to noon, we're going to continue to add 12. So 1 o'clock would be, 1 p.m. would be 1300 hours, 2 p.m. would be 1400 hours, 5 p.m. would be 1700 hours, and so on and so forth. So again, in real life, when we use universal time, we would say 0800 for 8 a.m., 0100 for 1 a.m., or 1300 for 1 p.m., or 0138 for 1:38 a.m. in the morning. Thank you for listening to this lecture that covered Unit 1 in our Math Basics for the Healthcare Professional. I hope that you found it a helpful review in going over whole numbers. I know we are already really familiar with this, but I hope this helped to clarify any questions that you might have regarding the material in Unit 1. Thank you.